My name is Chung Pui Xian and my matrix number is 291969. Now I'm going to present my individual assignment of intermediate calculus. So what is ordinary differential equations? An ordinary differential equation (ODE) in mathematics is an equation relating a function f of one variable to its derivative. It contains one or more dependent variable with respect to one independent variable. They are important in mathematics because they allow us to model and predict the behavior of systems. ODEs are used in physics, engineering, biology, economics, and computer graphics to study things like motions, populations, dynamics, biochemical reactions, economic growth, and simulations. So here we know that the y is dependent variable and x is independent variable. First, we need to know the ODE and PDE. ODE is contain one or more dependent variable with respect to one independent variable. Here is the example of ODE. And the second is PDE. PDE is involve one or more dependent variables and two or more independent variables. And here is the example of PDE. First, we need to know what is order and degree of a differential equations. So the order is determined by the highest derivative, while degree is the exponent of the highest derivative. Here is three examples of the differential equations. The first example, the order is 1, degree 4. The second example is order 2, degree 3. And the third example is order 3, degree 1. So in ODE, we will learn what is linear differential equations. Linear differential equations is dependent variables and their derivative are of degree 1. And the coefficients of the functions can be non-zero, zero functions, constant, not constant, linear or non-linear. And here is the formations of linear differential equations. And here is the example of the linear differential equation. So next, we will learn what is initial and boundary value problem, IBP and BBP. In IBP, we have initial condition, and in BBP, we have boundary conditions. So the difference between IBP and BBP is the highlight here. In IBP, the y is changing, and in BBP, the x is changing. In ODE, we have to know 4 types of solutions, which is general solution, actual solution, explicit solution, and implicit solutions. And here are the definitions for each types of solutions and the example. So we have 4 types of first order ODE. So first is separable equations. This equation is separable since the variable can be separate. Here is the example of the equations, and we must make the equations in the form fy dy gx dx. So the example here, we first need to make the equation into this form. Then we integrate both sides. Finally, we will get the equations of y in left side and x in right side. Second, we will learn what is homogeneous equations. So first, we must determine what is mxy and what is nxy. If m and n have same degree, we can say that the equation is homogeneous. So here's the example of the equations. We first need to add z in the equations in front of x and y and make it into this form, z power n fxy. So the example here, we can know that the function fxy is homogeneous of degree 5. So third is exact equations. A dE n dx plus n dy equals to 0 is exact if and only if the derivative of m with respect to y and the derivative of n with respect to x is equal. So here is the example. So we can see that the derivative of m and n is the same. So it is the exact equations. So after that, we will integrate both equations. So we will merge these two equations, these two functions. So we use the initial conditions to find the c and substitute into the solutions. We get the final solution. Lastly, we will learn what is the first order linear equations. First, we must make sure the equations are in the form y prime plus pxy equals to qx. And here's the example. First, we need to determine the px and qx of the function and find the integrating factor, which is exponentials power 2 integral px dx. And third is write down the equations. And finally, we will get the final answer with constancy. So we have learned 4 laws in application of first order linear equations. That is the Newton's law of cooling, exponential growth and decay, electric circuits RC, and vertical motions Newton's the second law of motions. So we will apply these all laws in solving our problem in daily life.
Next, we will look at the application of Newton's law of cooling. The Newton's law of cooling is given by the following equation. dt over dt equals to minus k bracket t minus ts bracket. While dt over dt is the rate of change of temperature with respect to time. In order to find the solution for dt, we will integrate both sides. Finally, we will get the T equals to Ts plus A e power minus k kt, where A is equals to EC. So we will get a new equation in order to find the temperature, that is Ts plus Ae power minus kt. According to the equations given, we know that the room temperature Ts equals to 10 degrees Celsius. When time is 0, the temperature is 90 degrees Celsius. When time is 30, the temperature is 30 degrees Celsius. So the question is asked for the temperature after 20 minutes, that is T equals to 20. What is the temperature? So we will use the formula T equals to Ts plus Ae minus kt. So we will use the conditions given to find A and K. So when T is 0, the temperature is 90 degrees Celsius and the temperature S equals to 10 degrees Celsius. So we substitute this information into the equation. That is so we will find the A equals to Xt. So the new equation is T equals to 10 plus Xt e power 2 minus kt. So next step, we will find the K. In order to find the K, we will start when T equals to 30 and the temperature is 30 degrees Celsius. So 30 equals to 10 plus Xt e k. So e power to negative 30k equals to 20 over Xt. So k is equals to negative 1 over 30 ln 1 over 4. So we will get the answer equals to 0.04621. After we find the value of k and a, we will substitute this all value into this equation. That is t equals to Ts plus Ae power to negative kt. That is t equals to Ts is 10 plus A is equal to Ft e power to negative k is 0.04621 t. Therefore, we will use this new equation to solve this question. That is, we will find when time is 20, what is the temperature. So we will find the T equals to 10 plus Ft e power to negative 0.04621 and T is equals to 20. So we will get the answer for the 1.75 degrees Celsius. That is the answer.
In conclusion, ODEs are a fundamental concept in mathematics with wide-ranging applications in diverse fields such as physics, engineering, control system, populations, dynamics, economics, biology, medicine, computer, graphics, etc. They enable us to quantitatively analyze the behavior of systems over time, making predictions and optimizing design.